Good afternoon, my YouTube viewers. It is Crystal here. Haven't made a video in a few days because I've been a bit busy doing other things. But I decided to go ahead and enter a Kaggle competition. It's their playground competition, and it's season 3, episode 26. And this is the last competition of the year. And so, basically what I decided I was going to do, I didn't really decide I was going to do, is Kaggle said that they wanted us to predict on probabilities on 3 classes in a cirrhosis dataset. And so that's what I'm doing. And so I made the metric that they were used to grade this competition was the log loss, and I have limited experience with log loss, but sklearn, which is Python's machine learning library, does actually have a log loss function, and so I used sklearn's log loss function. I'm not sure that I used the right one because you're supposed to use like a multi-class log loss function, and I'm not aware of sklearn having a multi-class log loss function. But I went ahead and got a 79% on the log loss, which the way that they score it is the lowest score is the best. So whenever I originally did it, I had like a 95%, and then I rejigged the figures and I got a 92%, and then I tried a different model being Logostic Regression and I got a 79%. So that's what I was able to get on using Logostic Regression. So a lot of people scored better than me, so there's lots of room for improvement. And if you wanted to see, how you can improve, you can always look at the code function of the competition, and there will be people who scored much better than me. But I decided to go ahead and make a video of my competition questions since I went to the trouble to actually compete in the competition. Unfortunately, I don't have a lot of time to try to improve my score because I'm doing other things. Like at the moment, I'm taking a course on mathematical thinking with YouTube, and so I'm not sure I'll have the time to improve my score, but this is my code. If you want to look at it, you can always look at it and try to improve it. And what I will do is I will leave a link to the code in the description box down below. So the problem statement is going to be predict probabilities on 3 classes in a cirrhosis dataset. So it was C, L, and D. So I'm not sure exactly what the 3 classes were. I'm not sure that I want to speculate, but it is to do with people that have cirrhosis of the liver. And then we're going to import our libraries, and I'm just using sklearn for this competition question. I didn't necessarily have to. I could have used, because they want predict probabilities, I could have used another model, but I'm better at sklearn than anything else, so I decided to use sklearn. So whenever you're programming in Python, you're supposed to import all of the libraries at the beginning. So that's what I did. I imported all of the libraries at the beginning. So we're going to import numpy as np to carry out your numerical computations and create numpy arrays. We're going to import pandas as PDs, which processes your data and creates data frames. We're going to import OS, which goes into the operating system. We're going to, from scipy.stats, import ks_2samp. That's going to perform a test. It's going to be Kolmogorov-Smirnov test, and that's what you need that for. From sklearn, we're going to import ordinal encoder, so we're going to encode all of the columns of data that are object. From sklearn, we're going to import train test split, so we're going to split the data set into training and validation sets. From sklearn, we're going to import Logostic Regression. That's your model that we're going to be using. From sklearn metrics, we're going to import confusion matrix and accuracy score, and that's just going to tell you what the accuracy is, and it's going to create a confusion matrix as well. From sklearn metrics, we're going to import log loss. So you want your log loss to be 0, which I didn't get a 0, but that's what you want. From matplotlib.pyplot, import matplotlib.pyplot as PLT. So that's visualize the data, and we're going to import seaborn as S and S to statistically visualize the data. Then what we're going to do is we're going to retrieve the files using the OS library. So we've got 3 files being train.csv, test.csv, and sample submission.csv. We're going to use the pandas to read the files. So this is the code to read the files. And we're going to set it so we can see all of the columns, pd.setOption, display.max columns, none. So that helps you to see all of the columns. We look at the train data frame, and it's got 7905 with 20 columns of data. So you can see your status is a D, C, or CL. And the status is your target. We check for info, and then when we check info, we can see that most of the columns are floats or integers, but you've got a few objects. We check for null values. There's not any null values, so you don't have anything to impute. We check to see what the unique values in status is, and it's D, C, and CL. We check for value count, so you got C is 4965, D is 2665, and CL is 275. We use Seaborn to visualize the target, and so you can see you've got more C's than anything else, and then you've got D's, and then you've got a very small number of CL's. So we're going to check our text data frame, test data frame, and that's the same format as the train data frame, except for the fact that you don't have a stage column, because your stage column is your target or your label. We check for null values. We can see that we don't have any null values, so that's good. And then we check submission. So when we check submission, you're going to have ID, status C, status CL, and status D. So that's what Kaggle wants to see when we submit our work. So we define our target. Target equals train.popStatus. So what that does is that pops status out of the data frame. We're going to perform a Kolmogorov-Smirnov test. And what that does is that checks to see if there are any columns in the 2 data sets that are not from the same distribution. So the ID and the age are not from the same distribution, so we just drop those. Now we're going to encode all of the objects and columns using sklearn's ordinal encoder. And then so you can see train and test. You don't have any more objects, it's all numeric. Now we're going to use Seaborn to create a heat map of the train data frame. So you can see this is the heat map, and you can see just looking at the heat map that none of the columns of data are closely correlated. You can look at core, so if you want to see the correlation, you can see the correlation. Now we're going to define our X and our Y variables. Your Y is your target, your X is your train, X test is your test. And then I set it up to standardize the data, but I think that with logistic regression, you don't need to standardize the data. But what I could do is I could go back after this video and standardize it and see if the reading improves with it standardized. But I tried random forest before, and you don't need to standardize it with random forest. And I was told that you don't need to standardize it with logistic regression. Okay. They're not sensitive to magnitude variables, so standardization is not needed before fitting these kinds of models. So that's what it's saying. It's saying that it doesn't need to be standardized. So I didn't standardize it, but maybe I'll go back through and try to standardize it and see if my readings improve. Now we're going to use sklearn to split the data set into training and validation sets. And now we're going to define the model, and in this instance I use logistic regression. So I set the solver up to Newton CG, and you can set the solver up for other optimizers. You can come over here where it says solver, and it says for multi-class problems only Newton CG, Saga, and LBFGS handle multinomial loss. So I can try SAG or Saga and see if that improves the score. Okay. And then I got 68% accuracy on that. So I could go back and try SAG, see what happens. It says I got a warning as well. And then we make predictions on the validation set. We've got 69%. Then we predict. Then we check the accuracy and create a confusion matrix. So you've got your accuracy and your confusion matrix. So now we check our log loss, which is the metric that Kaggle uses to measure this competition question. So we have a log loss of 79%. Check the probability. So we get a NumPy array with the probabilities for C, CL, and D, I believe it is the format. Now we're going to predict on the test set. So I made a mistake. I said predict on validation set. It's not the validation set, it's the test set. So I'm going to go through and update that anyway, because I'm going to try a different optimizer on logistic regression. And so when we predict on that, you can see that the array that you get. So now we're going to check, we're going to predict proba on X test. So you get a NumPy array for the 3 classes, what their probability is. And now I prepare my submission. Permission CL equals proba : 0. Sorry, submission status C equals proba : 0. Submission status CL equals proba : 1. Permission status D equals proba : 2. We convert submission to a CSV file, and then we read the CSV file, and here is your outcome. So I've got two things that I need to do. I can try a different optimizer, see if that improves my score, and I can correct that typographical error. So thank you very much for watching my video. If you like my video, please like, subscribe, and share. Thank you to my subscribers for supporting my channel. I'm going to go ahead and close this video, and I look forward to making more videos for you in the future.